All right, so it looks like that's enough time there. Most of the people have stopped joining at this point, so we'll get started here. So again, thanks for joining this webinar on inherent imperfections, knit lines, and party lines presented by Quick Parts, and we'll get right into it from there. So our speakers today, we're going to have John Zawarwitz, our VP of Sales. John Zadorowitz is actually pronounced that. Glenn Miller is our Senior Tooling Engineer. He's going to be our tooling specialist on this meeting. And then Brian as well, the Director of Operations here in Detroit. He is our plant manager in Detroit, has lots of experience in manufacturing as well. And then I'm speaking as well. I'm Matt Dietzman. I work in a sales role here at Quick Parts as well. So after that, I'll turn it over to John Zadorowitz to get us started.
All right, thank you, Matt. Thank you, everyone, for joining this afternoon or morning or evening, wherever you're at. On the agenda for today, we're going to talk about imperfections that we're going to come across with injection molded parts. Today is going to be around knit lines and parting lines. We're going to explain what they are, why they're there, where they come from, and how to I guess eliminate or mask them, as well as understand ways to limit the effect of them using different methods, whether it be design or surface finishes or things like that. So first, we'll start with knit lines. So what are knit lines? If you're not familiar with molding, so a knit line in an injection molded part is really referring to a point where you have two molten plastic flow fronts kind of meeting together. Typically, you're going to see this around voids in the part where you have like holes, bosses, and things like that. And off to the picture, or off to the right in the picture there, you're going to see some of those highlighted. They look like scratches almost in the part. So as the material is flowing through the mold, it's going to hit the opposite side of the hole, flow around the mold or the pin or whatever is there to create that hole, and then meet on the other side. So as that material is flowing, it's cooling, and it creates that knit line is what we call it. So they can come really important, especially if you get holes like with a lot, or parts with a lot of holes like grates or vents or anything like that, and it's a cosmetic part. That's where these can really come into play. Next. So, we call them knit lines. There's a whole list here of terms where everyone kind of calls them something different. They're weld lines, meld lines, seam lines, fusion lines, joining lines, and especially in the automotive space, you hear flow lines, which is not to be confused with another set of imperfections in molding. But so when we're talking knit lines, it could be any one of these terms on the left here. Next slide. So we kind of touched on this already. This is a little bit more of a visual here as to how they're forming. So we have material flowing in from the left. It's hitting a core and flowing around that and cooling at the same time, and then creating that weld or meld line. So on the left, right-hand side left picture, we have the pin or the core hole, and on the right, it's more of a V-shaped or notch feature where you can see the material coming together. You end up with the same thing, a light line or a scratch that's going to appear in the part. Oh, and before we go into this, if you have any questions throughout the webinar, feel free to submit them via the Q&A button at the top of the page here, or the top of the app. We'll get to those at the end here.
John, you want me to jump in?
Sure, go ahead.
So this is Brian. Why do knit lines form, or how do knit lines form? The graphic on the left is an excellent example. Just imagine a river that has a rock in it. And as the water flows around the rock, it goes around the rock and then comes back together. Well, it's the same premise, except in plastics, that hot materials cooling down, and when it comes back together, it may not fuse as it was before it hit the opening. So the process on the left results in the part on the right where you can see the two flow fronts come together. They've already lost some temperature. And even though they're still fusing together, they still will show remnants of gas and other imperfections of it having to come together around the hole. All right. The effects of knit lines. When you have visible knit lines, it's obviously an aesthetics and appearance issue. You can see it, like John said earlier, it resembles a scratch. So if you have a part that is a Class A surface or it's a visible that is important to be, without imperfections, knit lines can be troublesome. And then we also have the invisible knit line, which it's still there, but it's not showing. When you get that, it will affect the mechanical property of the part and the structural integrity. If you have a tab that goes around a boss, and that's the last place to fill, those can be susceptible to breaking because you have no support around it and it's the last spot to fill. Next. So strategies to reduce the knit lines. You can optimize the part design, optimize gating, the material selection. There are some materials that are less susceptible to appearance issues with knit lines. You can do multiple processing changes with the parameters to change fill speed or pack and hold and things like that to minimize it. And then surface finishing. The heavier the grain, you will hide the knit line more than a clear surface part. All right, I'll hand it over to Glenn.
All right, next section, we're going over optimizing of the part geometry. This is, basically trying to make your part geometry as moldable, as safe as possible. Obviously, we know that, these rules are not hard, fast, and, depending on what you need your part for, you can follow this and do as best you can. Number one, and this would go for any kind of cosmetic issue or fill issue, but in particular knits that we're talking about now. Uniform wall thickness is a big thing in injection molding. Plastic likes to flow through the same type of wall thickness. You run into issues when you go from thin to thick, back to thin, and restrict the flow. It creates all sorts of issues here. For knit lines in particular, reducing the number of holes, cutouts. It can be rectangular openings for a screen, anything like that. And also, if your part requires any kind of molded in insert, whether that be like a small round threaded insert for screws, try to reduce those as much as possible. Again, obviously you won't be able to eliminate these on some designs, but it's just something to be cognizant while you're designing your part. Reduction of ribs and bosses. It's a standard, any kind of boss or rib. The general rule of thumb for designing is no more than 60% of the nominal wall thickness of your part. You try to follow that. As far as percentage and thickness, you should be in pretty good shape. That will definitely help the fill and flow of your part. Try to limit any complex geometry, super fine details, thin areas, thin walls, anything like that. Just recommend that you try to keep that as nominal as possible and as simple as possible. Optimize the gating to attempt to reduce knit lines. Here's a list of things that you want to keep in mind as you're doing this. Strategic gate placement. Brian had mentioned that knit lines tend to get a little more obvious the further away from the plastic injection point, farther away from flow, the end of fill. So maintaining a gate location that kind of optimizes your flow and kind of minimizes that major melt front that we see in some of those previous images. In certain instances, 2 gates will help you. It's not always the case, but in certain instances, certain geometry, adding a gate can help with that. We tend to do a lot of edge gates. If you go to a sub gate or even a hot runner, a hot tip, that at least makes it easier to control the flow of the material. A cold sprue directly to the part is a little more difficult. You want to try to adjust the gate size or shape depending on your part, depending on how you're filling that. Sometimes that has to be done on the fly when you're running parts. May have to go a little bigger, may have to change the size and shape to adjust your flow. Valve gating, something that's done on more sophisticated tooling, parts that require, basically with valve gating, you're filling from multiple locations on the part, and you can turn off and turn on the gates as the flow of the material is coming over the second gate. You hit the second gate, that helps push that material through to the next gate, and then so on and so forth. So sometimes valve gating works on large panels, other types of geometry like that. Go through a couple of material characteristics that can reduce knit lines. A material with a low melt will definitely help. Not all material, this is a general list, not all materials, but in general, these are true. A high melt flow index can affect knit lines and the flow of material. Good melt strength in a material. Sometimes additives in the material can help. Sometimes they can hurt as well. Adding glass fibers to the material. There are different kinds, short fibers, long fibers. Here are a couple of materials here that we have listed. We use these types of materials quite a bit where we're at. Polycarbonate, ABS, and some of the filled nylon materials as well. Try to go over some processing parameters to help reduce knit lines. Processing just meaning the different adjustments you can make at the press. One of which is adjusting the injection speed, either speeding it up, slowing it down. Just trying to optimize the fill for this particular part geometry and that particular material that you're using, and try to kind of hone in on the best possible process and the best speed to fill that more uniformly. Definitely want to maintain as best you can the specs that come with the material. You want to keep it at the appropriate melt temperature. Higher melt temps increase the flowability of material. And depending on the cycle time, you really got to watch that sometimes, because you don't want the material in your barrel cooking, which can create all sorts of other issues with your material and your flow. You want to optimize your mold temperatures. That's different than the temperatures on the barrel, obviously. You want to keep your mold at certain temperatures. Sometimes you want to keep the core cooler and the cavity side hotter. Really just depends on the material and how your part's filling. Increasing of the cooling time. That's a big one. It can affect many things, but definitely as far as fill and flow and knit lines, the proper amount of cooling can really ensure more uniform cooling, and which puts you in a better position to have less issues with knit lines. Sometimes they're still going to be there, but you want to reduce the gravity of it as much as you can. Another important thing that we discussed at the beginning, surface finishing to reduce knit lines. A deep surface finish can hide parting lines, meaning textures, kind of matte finishes, engraving, things like that. That tends to kind of hide any imperfections like that. It also depends on the material. Most of these suggestions do depend on material. each material, these type of things will help a significant amount. Polishing also reduces the visibility of a parting line. Even the color of the material sometimes can hide the visibility of a melt line or a knit line. You really want to avoid the super high glossy surface finishes. You got your high A3, A2 polishes, things for lenses, things like that. Those tend to react a little worse when it comes to knit lines and flow lines.
All right, just to kind of summarize here on knit lines. So, knit lines are part of injection molding. It's really hard to eliminate them 100%. You can get very close, but you're never going to get away from them. So you can work to minimize them, but you're not going to eliminate them fully. So, think about your design, or when you're thinking about your design, think about materials. The processing side is really going to be left up to whoever's manufacturing and running the mold. Those may be two different people. Surface finishing, the overall geometry of the design, and the gate optimization. So, the gating you may not know up front, but that's where a good molder can help on the front end and help you, or at least give some suggestions on how to gate it or where to gate to eliminate or at least minimize net lines. Again, if you have any questions, feel free to submit them via the Q&A button at the top, and we'll get to those at the end here. So next, we're going to move on to parting lines. A little bit different than knit lines. So parting line is formed on the part where the two halves of the mold meet to essentially make the final product. Simple thing is with Play-Doh, you have a mold button, like pop in the Play-Doh and put the other half in and open it up, and you have a bunch of extra Play-Doh that's squeezed out, and that's what we call flash. But that line is the parting line. So we can see in the image on the bottom left, it's a very faint line, and on the right we can see kind of mold kind of opening and closing, and it's really the line that's between the purple and the red plates there. That is where it forms. All right, next. So again, there's multiple ways to talk about parting lines. We call them parting lines, but they're split lines, they're seam lines, mating lines, part seam, or the joint line. Again, depending where you're at or type of molder you're working with, these are all interchangeable. So on the right side, we have a picture of a parting line, a little bit more defined, so you can see it kind of carries around the whole outside of the part. And go to the next slide. So what are the effects of parting lines? They can affect the appearance of the part, the aesthetics. If you have a parting line going across a surface where someone may be holding the part in their hand or utilizing a hand tool or something like that, you really don't want a parting line going across there, because it's going to not necessarily be uncomfortable, but it can be irritating to feel that line. Parting line is going to add some dimension to the part. You're going to get a small amount of plastic. So, typically it's going to be no more than 5/1000ths of an inch. But if you have a really tight part, maybe mating parts that, fit one inside the other, that could cause some issues on your stack up. And then, as I mentioned, the assembly issues that come from the dimensionals. So in the picture on the right, we have a parting line that's kind of in the middle of the part. It's drafted from both sides. So, part of the part is buried into the core and the other half is in the cavity. We have that parting line in the middle there. And then next, I think Brian, this is you.
Yep. Types of parting lines, vertical parting line. This is the most popular type of parting line. It's formed in the perpendicular direction of the mold opening. So this is very similar to the slide a couple back. Most importantly is to look at where the verbiage says vertical parting line. That is, if this was a perfect half and half, you'd see the parting line going down the vertical seam and directly in the middle of the part. All right, next slide, please. Another type parting line, the curved parting line. It forms in a curved direction, as in if the part's not completely straight, the parting line will most likely go along the axis of the shape of the part. So, you know, perfect world, each half is equal and they come together in that middle. Next, please. And then other types of parting line, you have beveled parting lines, step parting lines, and comprehensive parting lines.
Next, we'll take a look at some strategies to try to minimize parting lines. And like we said, you know, there is going to be a parting line seam. It's part of injection molding, but there are some things you can do to help kind of minimize that depending on your geometry. Mold design considerations, of course, kind of orientate the mold to have a parting line that's on a non-cosmetic or non-functional area. You know, depends, say you have a box that has a little draft on the sidewalls. You want to put that parting line as close to the bottom lip of that as you can, hide it on a radius, something like that that's not obvious. You know, try not to put a parting line in the middle of your part. It's all about the draft of the part. The part has to come out of the mold. So depending on the draft, you have to really pay attention to that to get your parting line in a location that's going to be the least, I'll use the term, the least ugly or obvious. Material selections, obviously, and that goes for anything in your design. Material selection is important. You want to try to avoid some transparent materials. Just tends to really, you know, show that. I mean, you can look on any kind of bottle or any kind of cylindrical thing. If it's clear, you're going to see that parting line is pretty obvious. High shrink materials are slightly less likely to show parting lines. Just because that material is shrinking quite a bit and it tends to kind of mask that parting line a little bit as it shrinks. Parts that aren't, you know, forward facing, meaning, you know, non-cosmetic parts, something in your general assembly that say the customer doesn't see. Parting lines on those types of parts can be kind of hidden depending on the mating pieces that surround it. Obviously, the processing parameters at the press itself. You want to watch your injection pressures. The clamp force of the press is important. You don't want too weak of a clamp on your press, so it doesn't hold those cavity and cores together tightly. You know, the tighter those are held together, the less likely you're going to get a seam, the less likely you're going to get seepage of the material, which causes flash, which is a big no-no in molding, which we try to limit. What we try to do a lot of is preventative maintenance on the tools. That really helps a lot. You want to make sure you're maintaining your parts, make sure they're clean. You prevent wear, damage, anything like that. Anything that can put a funky edge on your parting line steel. You want those to be sharp and crisp and clean. So you kind of have to watch those. Readdress them as you need to. As the tool gets older and older and runs more shots, you really have to maintain that. Parting lines, you know, they become loose and weak. Like I said, you get rolled edges, as we call them. So instead of a nice sharp 90-degree edge, they start kind of bowing over. They get worn. They get smashed. You know, close a part up accidentally in the tool, it can damage the parting line. basically you have to consider two big pieces of metal that have to go together perfectly flat, no gaps, no seams, because what you're trying to do is make a seal around that so that the material doesn't leak out of there. So you want to watch for any wear or damage on those that would cause rather obvious parting lines. So this is a quick summary here on the parting lines. Like we said, we do everything we can, but there will be a parting line seam on your part. It's just how well we design around your geometry, how well a draft you have in your part, how tight the tool is, all of those factors. The maintenance on the mold, the orientation of the mold, the processing parameters, the gating, all of those can help, with the general cosmetics of your part and your parting lines.
All right, I think that's the end of our initial presentation here. So we'll go through a little bit of facts about quick parts here. Then we'll kind of get into a review section and answer any questions you guys have about the presentation so far. So again, a little bit about quick parts. This presentation was presented by Quick Parts, around for over 23 years, over 100 million plus parts sold, a lot of experience in our operators and engineers, unrivaled flexibility. So we're willing to do any kind of project you guys have. Very responsive customer service, and we're always updating our technology to meet the customer's needs. And this doesn't just go for injection molding, this goes for 3D printing, cast urethane, whatever you guys are looking for, we likely have the process that fits your needs. So again, those are just a little bit of background about Quick Parts in general. And then just a quick announcement here as well. I do see the one message in the chat. Someone's asking about future trainings. So we do have some upcoming webinars as well, kind of continuing this series, talking about these imperfections that you see in parts. So August 29th will be the warp, sink, and shrink one. We should be able to talk about some voids in there as well, going out to Scott Townsend. So thanks again for submitting that question. And then September 28th, we'll be doing short shots, flash, and burn marks. So yeah, this is kind of what we have on the agenda for upcoming trainings and webinars. So if you guys want to see anything else, though, feel free to let us know. We'll be happy to put those on the schedule as well. And then we'll turn it over for questions here at the end here. And again, if none of your questions get answered or you do have additional questions afterwards, feel free to reach out to us at sales@quickparts.com. But I'll turn it over to John Sidorowitz here to answer some of the questions we have.
All right, thank you, Matt. All right, looking at the questions here, Matt, I think you touched on Scott's question here about mitigating sink and voids. So yeah, the future webinar coming up is going to be all around wall thickness and how that can affect parts, creating voids, sink, abnormal shrink, warp, those types of things. So look for an email on that shortly. Next up, question for the team: could different surface finishes allow material to flow differently and therefore affect the knit lines?
Yeah, it definitely can. Absolutely. A high polish, obviously, and it really depends on the material too. There's no hard, fast rules for everything, but there are times when you have some sort of grain on your part, the material will flow a little differently. Nothing too extreme, but it will tend to affect it a little bit.
To add on, not just graining the cavity, graining the core side too, if possible, can definitely help. It as the material flows over they're small, they're tiny little pits in the grain. It does help break up that flow and could improve the knit line.
And another thing with the graining, little trick that we tend to use where we can, if you got a 50-50 part, meaning half in one half of the tool and one half in the other, sometimes we'll put a little grain or texture to the core side to assure that the part comes out of the cavity half of the tool. But just a little trick that gets used at the molding press.
All right. Next one: how can simulations help in mitigating the formation of knit lines? I'm assuming
it's more about predicting it, right? It's the mold flow gives you a general, here's where your material is going to go, here's going to be the end of your fill. It's more about predicting where it is and then try to adjust from there. That's a good animation right there. We're flowing around that hole, and you can visibly see where that knit line flows. that's part of a mold flow right there. That's showing you how this material is going to go through your part in simulation. And you try to make adjustments and try to make predictions based on that. But it is a simulation, so it's the best guess, so to speak.
Okay. Scroll through here. What's the difference between a parting line and flash?
Glenn, you're muted.
Sorry about that, folks. Like we talked about earlier in the presentation, you want to have a good clamp on your press, because basically the injection pressure of that plastic is trying the entire time to force those halves apart. The flash and the parting line seams are intertwined, obviously. A nice tight parting line, you just get a seam line. A loose parting line or damage to the parting line, and the material is allowed to seep out and cause flash. So really important to maintain those parting lines.
So we have one more here. This is, I guess, really for the mold makers. What role does a mold maker play in the management of the parting lines? I think you kind of touched on it on the couple slides forward on the molding maintenance, but
yeah, I mean, obviously, in the initial build, we do what we call spotting, which means you put the two halves together, apply pressure to it, check, you kind of color up the one half of the mold, you check the spot to make sure everything, both sides are hitting hard on each other, making sure that that's tight. And then again, as the tool gets older and runs more parts, it's the job of the tooling team to maintain that, to make adjustments, reaffirm the sharpness of the parting lines and things like that. The tool maker is kind of the doctor for the tool.
okay. One more just came in here. Can you explain the difference between a visible and a hidden parting line? What considerations a designer must keep in mind when deciding between the two?
Well, visible parting line is something that, you have a very show part. There's going to be a parting line. We depending on the type of part it is, there's going to be a visible line that's probably going to be seen by the customer. A hidden parting line is somewhere where you can kind of tuck that parting line in somewhere that isn't obvious, that isn't, forward to the customer. Maybe it sits down in another component and it's hidden. That's kind of the difference there.
Okay. All right, that's it for the questions, it looks like. Oh, we just had one more come in. Any way to completely remove parting lines? I mean, I can take that one. If it's a visible parting line, and we've had some instances where we've had customers that had parts where the parting line had to be, in a certain area just due to the design and to make it work and moldable. The last resort and is post-processing, where it's either sanded off or removed. And typically in those cases, the parts are painted or something along those lines, or coated to cover that. But I don't know, Glenn, Brian, if you have any other thoughts.
No, I mean, that's what I was going to say the same thing. If it's some kind of post-process where the seam can be cleaned up or painted over is really the only real option, unless you've got a cup where you can bury the whole thing in the tool, but there's still going to be a seam at one of the edges. So, I mean, it's impossible not to have a parting line somewhere.
The goal is just to minimize it and hide it the best you can.
Yeah. All right, Matt, back to you.
All right. Yeah, there's no more questions. I think we'll end it there. And again, if you have any more questions that didn't get answered here, you have more you think of later, sales@quickparts.com is going to be the best way to reach out to us. We'll get you in touch with John or Glenn or Brian to get you the answer you need. So yeah, thanks again. I think we'll end it there.
All right. Thank you, everyone. Appreciate you joining.
Great day.
Have a great rest of your day.